the arena here on the Mississippi Gulf Coast is really an economic generator and has been since the day it was built. The amount of people that we bring into town on an annual basis exceeds 500,000 year in, year out. And those people come in, they spend money, they eat in our restaurants, they play in our casinos, they stay in our hotels, they shop in our stores, they buy goods and services. And that's what we're here to do, is to drive the economy and bring more business to town.
The Mississippi Coast Coliseum was built back in 1976. It's an easy drive for the entire coast. People are happy to come down and come see a show. This is considered a medium-sized venue. We do multiple different shows here. We do dance recitals, we do country western, we've done drama shows, we do summer fairs, festivals, and so we're a multi-function facility. Yeah, the Coliseum has had a reputation in the past that it was a hard rig. And all the promoters knew that coming into it, and the riggers for these various touring companies, they knew that coming into it.
The reason that we pursued getting a rigging grid in the arena was the fact that we'd had complaints for many, many years from touring professionals, from tour managers, from artist representatives, the artist agencies, that Biloxi's too hard to play. It takes too long to rig, it's more expensive to rig. We have to have a day before for the bigger shows to where we can pre-rig, and it just doesn't route into our plans on how we have to route the tours. And so there were so many shows that passed over us, and so many shows that never even called us because they had that information. So we knew for a long time that we needed this apparatus. No question that we had to have it. It just really became a matter of how do we afford it. We were fortunate to get funding through a BP Restore Act grant that our Governor, Phil Bryant, made sure that we got. And that grant is what's allowed us now to engineer this project and get it installed.
My role as the administrative piece of this and the paperwork is making sure every requirement that the Department of Treasury requires, that we complete all of that with MDQ, and then work with the engineer, Simpkins and Castelli, and Ron Luchin, our technical director, who has all the experience of the grid, the initial grid system, and what we need going forward in the industry and production, to Matt, our executive director, who knows the building so well, and then working with Simpkins and Castelli and then we get everybody else involved, like the XSF and the manufacturing and the fabrication of what we want to see for the building. So there are so many moving parts and people involved on the team that it is truly a group effort to see a project like this come to life.
We went to the engineers and asked them what we could put in this building.
We're a civil structural engineering firm, and we've been working for the Coliseum for at least 25 years, helping them on shows, rigging, and so forth. And early on, probably around Hurricane Katrina time, we were presented with the need for a grid. Some of the challenges that we faced trying to understand the structural nature of this geodesic dome. It's a steel-framed structure, and we had no information from the original designer, so we had to cobble together our own structural approaches.
My role was to do the analysis of the roof structure to make a 3D model and determine what the capacity of the roof might be. With this analysis, we looked at shows that were touring now and trying to look at some of the heavier shows and determine what they were and be able to take that and maybe increase it a little bit. The limiting factor for this building was the roof structure because it's existing. These trusses are capable of supporting far more than what the roof is.
What we see is arenas that have a long 2-day load-in because of the challenge of the facility. Taking a system like this, spending a month to get it installed, turns all of their big, heavy shows from 2-day load-ins to 1-day load-ins.
So this new grid system is capable of spreading the load because it's much wider than where the hangars were before. They've got many more points that they can hang from on a 15 by 15 grid, whereas before they just had cables at random spacings that they had to swing and make bridles, and a lot of times they were bridling between existing structures and not even using the hangars. One of the first challenges that I encountered was in the analysis of the dome structure is fitting a square grid into a round dome, getting everything to line up and hang properly. You didn't get to hang it exactly like you would prefer, so that was a challenge. And then we were looking at a steel grid system, and the weight of that was just so great that we started looking into the aluminum system, which I wasn't very familiar with, but working with XSF, we learned a lot and were able to get a system that worked.
With a dome like this, it's just so difficult because every single point in the air is at a different elevation, which means all of your rigging, steel, your bridles become much more difficult and more time consuming to run through all those calculations and get everything in the right spot and at the right elevation. Whereas when you have a flat, level grid with rig points every 15 feet, as well as truss going, a grid in both directions, and those motors go in super fast. They go up fast, they go down fast. And that's where you overcome the challenges of loading in and out of a show like that.
We've had 2 or 3 different designs, and XSF had the best one.
Originally, we were contacted by Simpkins and Costelli. It was just a basic, kind of reach out and see, kind of feel us out and what they should look for and what kind of load ratings that we could provide and what kind of different options we had. And we gave them some, additional information and some drawings and specifications on our truss, and they developed the bid package for the Coast Coliseum.
XSF was able to show us a lot of past projects that they've done, and they had a lot of information about different loading of trusses and industry standards of spacing so that we could make sure that we were getting the Coliseum exactly what they needed to stay up to par with all the other event venues.
Fortunately, we had the right engineer that understood this building and knew this building better than any other engineering company in America. And they were able to reach out and find the right parts and pieces and make it all fit into the bid process.
Once they had the bid package developed, then of course it goes out for bids at that point. General contractors bid on the project, J.O. Collins wins the project, and then we become a vendor for J.O. Collins. Then after the bid was awarded, we developed a set of shop drawings, or basically rough concept drawings. We think the truss will be this size, we think we'll connect it using this connection, we think your load ratings will be approximately in this range, but we can't confirm that until we go through engineering, and that's where we use Clark Reeder Engineering for this project. So we turn all the documents over to Michael. Michael approves the general design. General design goes to Clark Reeder. Jeff Reeder does all the engineering on that. So it took a couple of months to get the engineering ironed out, and then once that's all approved, we put the project into fabrication, develop the shop drawings. It goes through our shop, we fabricate it, we put it all together, put all the truss together in our shop, take it apart, go get it powder coated, and then the Coliseum had some space for us to store the product. So we would, when we had a full truckload, we would send a truck out. They would store it off to the side. 2 weeks later, another truck comes out, and they store that off to the side. And so it's all here waiting and ready.
I've been working through on this process and seen many drawings, pictures of the truss system from XSF, and just seeing the way their shop drawings came through, I was impressed with all of that. And when the material arrived here on site, we came here and unloaded it. Myself and an operator came here and unloaded it. I was very impressed by the quality of the material. The welds were exceptional on it. Everything looked like it was packaged up real well.
As we moved it into the arena and started unwrapping it, the workmanship came to light then. As
it goes together now, I'm finally seeing the fruition of all this work everybody's put together, and I'm very pleased with the quality of the work.
The main benefit for having a grid like this put into a 43-year-old building is now we're not just a 43-year-old building anymore. We're a building that can handle large amounts of weight. They can get in one day and do it efficiently, keep their labor bills down, and it allows us to bring in more shows that we were losing because of the inability to rig in this building efficiently.
You know, we're not old school 1977 Coliseum anymore. We're doing these upgrades for our guests to give a better experience and a heightened experience and more exciting experience. And it's so exciting seeing something like that being executed, knowing what it took to get to this point. For me, again, the safety is such a big deal, so I just see like, wow, this is so much better than where we were. So the safety aspect of the truss system is phenomenal. The safety system that was put in place by XSF is great. Just overall, seeing this brand new black truss system that I just know how easy it's going to make our production. It's going the money it's going to save us. We've also got a great team of riggers. I mean, they can come in now and have more confidence in their job and what they're doing and enjoy what they're doing a lot more.
Yeah, so the original loads that were being hung from this building were roughly 70 to 80,000 pounds on average, and they were having to swing in order to hang these shows. And now just the A stage alone will be capable of supporting 120,000 pounds with added capacity from the center and B stage supports.
You know, it started off with the engineers, and of course that had to go through a bidding process. And then we've got the main subcontractor, which is J.O. Collins, and the supplier is XSF, and the assembly company is Tim Conder.
You know, once Tim was awarded the project, we had weekly meetings set up with Clark, just whether we needed them or not, just to make sure we stayed on top of any design changes, any engineering changes, anything that would affect the installation.
The team that I'm responsible to, which are the engineers, XSF, the venue, I really see my role as being some of the glue in between those. The engineers have worked together for months to come up with what XSF can build. XSF builds it. There's an expectation from the venue, and then I kind of tie together those entities to execute these plans that have been going on for over a year.
Now it's beyond just designing a truss system. Now it's how do we actually fit these two grids in between those three catalogs. In a dome like this, we're trying to put a square grid under what would be considered, you know, a geodesic framework. So the rig points that are hanging the truss are not necessarily on a uniform 15-foot by 15-foot grid. However, from a rigger's standpoint, underneath the grid, they're still able to hang load off of it as if it's being supported on a 15-foot by 15-foot grid, which simplifies things for riggers on site. Kind of a semi-sporadic support layout with a very uniform rigging layout underneath.
So the general process is when XSF has shipped their equipment and we've received it here at the venue, we inventory it, we spread it out, we have a timeline and daily plans of where we're going to work and what we're going to accomplish. The plan is to put a piece of the grid together today that gets attached and flown up. By attached, we have riggers that go up in high lifts. There's no existing way to reach the ceiling, so we have to have riggers go up in a lift, and we have a hoist package for them to basically rig to the ceiling. We attach to the XSF truss, pull it up and attach it to the roof, and then we dismount the hoist package.
So after 2 years of preliminary design and bid documents and engineering and fabrication, and now we're here in the middle of installation. We've got the grid B, the smaller grid, is already up in the air. Grid A is going up in 3 lifts. So the stage right lift is already in the air. Stage left lift is going up almost as we speak. You can hear them working in the background. And then the center stage portion of grid A is already assembled down there on the floor. It's on casters. And once the 2 outside thirds are in place, we'll roll the middle one in and lift it up and get it all in place, bolt everything up in the air, and we're just probably 2 days away from having all this flying. And it's exciting to see it.
So many people were so used to the last 40 years of this building. Not many things had changed. We're doing major changes. to make it that much more fun to be here. People are going to want to be here more often.
Walking into that room and seeing the grid being assembled and hoisted, it just gives you a feeling of pride and accomplishment for what we were able to do through the engineering effort and with the support of everybody that worked with us.
It's a lot bigger than you would think, than a piece of paper would show, but it is exciting, and it's just a relief knowing that it's finally here.
As far as this project goes, it's really exciting to see the truss grid finally up in the air and to realize everything from paper to material on the ground and then see it in place.
They've expressed to us that this is exactly what they needed and exactly what they wanted, and it's going to change the way they do business here for the better.
We are so excited for this future of this building and our capabilities now and what we can do. Bigger, better, beyond what we've done before. We've really enhanced our guest experience here at the Mississippi Coast Coliseum and Convention Center, and we can't wait.
Biloxi has now got a system to compete with the rest of the nation.